Hi, welcome back to our third example from normal problems. In this problem's going to be a little bit trickier than the last two problems. We are still going to follow the 6-step process, although we may have to cycle back through some of the processes to really figure out what's going on in the problem and solve it. The first three, we might have to cycle through 4, 5, and 6 a couple times. But let's start with step 1, interpret and define. U.S. internet users spend an average of 18.3 hours a week online. If 95% of users spend between 13.1 and 23.5 hours a week, what is the probability that a randomly selected user is online less than 15 hours a week? Interpret and define. Okay, so an average of 18.3 hours a week. We now know 95% spend between that. What is the probability that a randomly selected user is online less than 15 hours a week? Okay, so my random variable X, interpret and define. So let's see here. I'm looking at internet usage by internet users. So this is going to be the hours per week. This is also going to be my units. So maybe this is my units. So this is time spent online by an internet user. So that's my random variable X. That's what I'm looking at. And now I'm going to check. So as I read through this, there's nothing that tells me that this is a normal probability distribution. I need this to be a normal distribution to continue. So what I am going to do is I am going to say that I am assuming that this is approximately normal. So I'm going to write that I'm assuming it's approximately normal. If that's not a valid assumption, I can go back and fix things later. I want to make sure that I've stated that I have made that assumption because it wasn't told to me. I need to make sure that I can remember later that I use that this is a normal model. So now let's find my parameters. So 18.3 hours per week is the average, and I do not see a standard deviation. And this is an issue. I don't know what to do. I'm stuck. But the good news is we have z-scores, we have x values, we have areas. We can go back and forth between all of these, and we're going to be able to figure this out. So I kind of have two pieces of information here. I have a range of hours with a percent, and then I have a probability that I want to find. This probability that I want to find is going to be this is going to be my question. This first piece is going to be a tool that I use. So let's actually draw a normal model with our first bit of information in there. And because I don't know the standard deviation, I'm just going to write sigma. So I know that that area in between those is 0.95. But I don't know the area to the left of either of these. I'm a little bit stuck here. But what I'm going to do right now is I am going to look at these. So I'm going to say 23.5 minus 18.3. This difference is 5.2. And 18.3 minus 13.1. This difference is 5.2. This is symmetrical. Okay, so 13.1 and 23.5 are both 5.2 units above and below 18.3. That means this is symmetrical. Because my distribution is symmetrical, I know that these have the same area. So if what's inside here is 0.95, what's outside that has to be 0.05. So the total area outside is 0.05. Okay, so to figure out what's in each of these, if it's symmetrical, each of these have to have the same amount. So I'll divide that by 2. So each of these has 0.025. So each of these values has 0.025 outside of it. Yay. So this is helpful, but I can't really do anything with my calculator yet because both my normal CDF and my inverse norm require me to have a sigma. But I notice that if I'm using z-scores, my standard deviation is 1. My mean is 0, standard deviation is 1. So z distribution has a standard deviation that I know. So I'm going to call these z left and z right. I really only need to find either z left or z right. I don't need to find both of them, but I am going to go ahead and find both of them. So if I want to find z left, I'm going to say that z left is the inverse norm of the area to the left of z left, which is 0.025, 0, 1, and z right is inverse norm of 1 minus 0.025, which is 0.975. So the area to the left of this value, or this value, is 0.975. So 0.975, 0, 1. So let's do both of these calculations. Negative 1.96. And positive 1.96. This makes sense because our distribution is symmetrical and we've got the same area outside, but I really only need one of them. So I think what I'm going to do is I'm going to work with this. So what I know is this formula here. I know that z is equal to x minus mu divided by sigma. I know z. I know the x related to that z. I know mu. I don't know sigma. So what I'm going to do is I'm going to plug in the values I know because I now know 3 of the 4 values. That means I'll be able to find the 4th. So this is negative 1.96 is equal to 13.1 minus 18.3 divided by sigma, or negative 1.96 times sigma is equal to negative 5.2, or sigma is equal to 2.65. So this is my sigma for the problem. That now means that I know both the mean and the standard deviation. So now that I have calculated, I am able to go back up and answer my final question. So I want the probability that a randomly selected user is online less than 15 hours a week. Draw my normal model. Less than 15 hours. 15 hours is here. So I want the probability that x is less than 15, which is that area. Now I have an x value and I want an area. So I am going to use my normal CDF. So this is now going to be normal CDF. The left limit, which is negative infinity, we approximate with negative 1e99. The upper limit is 15. The mean is 18.3, and the standard deviation is 2.65. Negative 1e99, 15, 18.3, 2.65. And that gives me 0.1065. So what this tells me, I now have found the probability that answers my question, so I'm finally able to move on to my translate step. So what does this mean? Well, this means the probability that a randomly selected internet user is online less than 15 hours a week is about 10.7%. And that's our final answer. We had to cycle through our process a couple times, but we were able to get a final answer translated into language people understand.